In Wagner-Merwin rearrangement, when an alcohol containing more than two alkyl or aryl group on beta carbon are treated with acid, the product formed is generally a rearranged product rather than simple substitution or elimination product. This reaction is called as Wagner-Merwin rearrangement. The newly generated carbocation is stabilized, generally by loss of proton to give olefin, and less often by nucleophilic substitution or loss of some other positive group. As shown in this reaction, we have a secondary carbocation, we have a secondary alcohol, and this secondary alcohol is going to react with this proton. We have provided it with a proton, and it is going to form a secondary carbocation. This secondary carbocation is going to undergo the rearrangement, and this alkyl group, which is simply R, is going to migrate from position 1 to position 2, and after that deprotonation is going to happen, and which will result in the formation of an olefin. Mechanism involves the rearrangement of carbocation intermediate. So we have this whole mechanism discussed. As I told you earlier, we have a secondary alcohol which is going to dehydrolyze and form a secondary carbocation. This secondary carbocation is less stable than a tertiary carbocation, so the rearrangement is going to happen. This R group, after rearrangement, it is going to deprotonate the carbon number 2, which is migration terminus, and which will lead towards the formation of an olefinic bond. The earliest example of Wagner-Merwin rearrangement was noticed in bicyclic terpenes. Here we have the example of camphene. So isobornyl is going to give camphene as a result of this reaction. In these reactions, double bonds is formed according to Zaitsev rule. Leaving group in this reaction can be hydroxyl or other leaving group like chloride or any other halogen, which renders the carbocation character to carbon atom. Direction of rearrangement is usually tertiary to secondary and then primary. So we have this reaction which is mentioned above. We have an alkyl halide. After protonation, HCl is going to remove, and this carbocation is going to be a primary carbocation. Then methyl group is going to migrate from this tertiary carbon to this primary carbon, and it is going to form a tertiary carbocation. And after that formation of tertiary carbocation, that carbon is going to lose a proton and is going to form the olefinic bond. Similarly, in camphenyl, it is going to make xanthine in the similar way. These There are an interesting example where series of rearrangement occur simultaneously. One example shown below involves a terpene 3-beta frenanol. This compound, on treating with acid, a 13 oleanine, is formed by 7 successive shifts, 1-2 shifts. And this is your homework. To You have to find out how is this going to happen. A textural description of this mechanism is going to be this. You can get a help from this chart right here. I have discussed the migrations which are going to happen. All these shifts are stereospecific and you can easily get it right. So this is the example of these reactions, so you can easily get it right. So yeah, this is your homework. And alkene, we have some other examples. An alkene in presence of Lewis acid and other suitable initiators can also undergo Wagner-Merwin rearrangement in the above tricyclic molecules consisting of 10 carbon atoms. Upon a series of rearrangement provide adamant. These steps are successive 1,2 or 1,3 hydride shift and alkyl group migration. These reaction takes place due to thermodynamic stability of adamantane or diamantane and similar diamond molecules formed as a result of rearrangement. Some other kinds of examples of for Wagner-Merwin rearrangement are given below. As we can see here, we have this ring. It is going to rearrange in the form of this. Here this is going to break and these two bonds are going to attach, which will form in the formation which results in the formation of this 6-membered ring. And now that's all for today. I hope you have learned this Wagner-Merwin rearrangement. Don't forget to do your homework because this is an interesting example